third question 1688. It says if bar AB has an angular velocity 6 radian per second, determine the velocity of the slider at block C. So we are given with the angular velocity at this bar, which is 6 radian, and the direction on the diagram shows that it is in counterclockwise direction. So we have to find the velocity of the slider at block C, which is over here, and from the diagram it seems that it is in a horizontal direction because it is in a horizontal guide in which it is moving. And from the diagram we know that the length of AB is 200 millimeter and BC is 500 millimeter. The angle of AB with horizontal is 45 degree, and BC has a horizontal, with the horizontal it has a angle of 30 degree. So in this we have to use the IC method. So first we need to find the direction of the velocity. So velocity of B will be perpendicular to AB, and as the 45 degree is the angle of AB with horizontal, so the angle will be 45 over here as well, and the remaining is 45 as well, because the total angle of VB with AB rod is 90 degree. And we also know that the IC we find, it is perpendicular to both VB and VC, and VC over here is already perpendicular, because as I mentioned before, it was due to that, as we see in the diagram, it is moving in a horizontal guide, so it is already horizontal, so it has a vertical direction to the IC, so it already has a 90 degree angle. And now we have to find the angles in the IC, which is with C and B. What are the angles in that triangle we have formed? So as VC has already 90 degree with the IC, so 30 degree is already the length given, the angle given with the BC rod, which is 30 degree. So we subtract it from 90 degree and we get 60 degree over here. And then we know that these two angles are 45 and 45 degree, and total is 90 degree. And we also know that the angle of VB with the line which is connecting B to IC is also 90 degree, because the velocities have are perpendicular to IC. So, and we know that over here, so we have to find where this 105 come from. So as we know that over here it is 45 degree over here, so if we extend this line to this bar, there will be angle over here as well, so it will form a triangle. So 30 degree will be 30 degree over here as well. So if we use the geometry of corresponding angles, so if we add them, it forms 75 degree. And when we subtract 75 degree from 180 degrees, which is the sum of all the angles in the triangle, we get 105 degree. And then we are using the 3 degree angle thing to subtract all the angles which are given to us, and we get 75 degree at the end over here. And then we have two angles on this side, and we are able to find the angle over which is at the point IC. So over here we are given with the angular velocity AB 6 meter per second, and we can use it to find the velocity at B, which is 1.2 meter per second. We convert millimeters to meters, so we divide it by 1000. And now we have to know the length like of B relative to IC and C relative to IC. So to find these lengths, as we can see, this is a triangle and we have all the angles inside it, and we have one length which is of BC, which is given to us in form of 5 millimeter. So we can use sine law over here. So we use sine law to get RB relative to IC and RC relative to IC. So by using sine law, we get RB relative to IC, which is 612.37 millimeter, and RC over IC relative to IC, which is 683.01 millimeter. So we get these values, and now we can get the angular velocity BC. We already have velocity B, and we can divide it by B relative to IC, because IC is the point which is like taken as a point, reference point, where it around which the velocity B and C will be acting. So that's why we divide B relative to IC, and over here we again divide it by 1000 to get length in meters, and angular velocity at B C is 1.96 radian per second. Now we have to find the velocity at C. So we already have angular velocity BC, and we have the length which is RC relative to IC. So we simply use our equation, we multiply them, and we convert this millimeter into meter, and we get 1.34 meter per second. And as you know from the diagram, the direction is towards the left and it is horizontal.